Hello Sparkers, this is Instant Kafka. I'm going to try to do a series on how to generate mazes. And the reason I'm doing that is because of this level right here. This is my current game that I'm working on. And it's basically just a circuit or flow type game. Go in here and you try to connect all the circuits together. You just finish this up real quick so I can show you why this has anything to do with mazes. Oh. As you can see, the speakers actually play music. I'm going to undo those for now. That goes there, that goes there. There we go. That's great. I've been practicing this and I still can't do it very fast. I've done this one 100 times already. Okay, so this is kind of the point of the game, is to connect all the little gizmos together, and they all do, I think, cool stuff. You know, we have a gear here, it spins around. Eventually I'm going to have that attached to stuff outside, other gears outside the playing field to make them spin around. We have these that actually play music, and each one that gets connected makes it louder. Then we have these cool little doodads that kind of, I don't know what they do, glow different colors. We have Sparky, creates sparks, and light bulbs. So, what does this have to do with maze generation? Well, if you look at the circuits here, the what are these called? The wires, I guess. It's basically a maze. You have all these different connections here. You have dead ends. All the gizmos here are dead ends. And that's how I want to generate randomly generate levels on this game, is basically generate a maze. So how do we do that? Well, let's create an empty world. Alright. Prop. Delete that guy. We don't need a human or a character in this. Okay. Grab a logic cube. This is going to be our maze generator. Maze generator. I like to color my logic cubes so they're easier for me to spot in my levels. And I use really garish colors, so. Oops. Yellow. Where's yellow? Yellow. There we go. Okay. That's nice and easy to spot. Alright, we have our maze generator. Now our maze is going to be a grid, an array, a matrix, whatever you want to call it, of cells. In my game, it's 8 cells across and 8 cells down. 8 by 8, so a total of 64 cells. Let's grab one of these, and this will be this will represent each cell. This one we're going to make visible. Don't need shadows. Let's make it purple. I like purple. That's almost purple. The head will make... Oh wait, that's not the head. The head That's a good color for the head. Oh yeah, Joker colors. There we go. May cell, cache arrows. Oh, and the other thing is we need to make this one a template. I'm going to create many of these, so that's a template. Run this. Okay, looks good so far. Now we need to be able to generate these 8 across, these cells, 8 across and 8 down. Go into our maze generator. This is our main page. And we're going to have an initialize page. In our main, we need to call our initialize page. Nope. If you haven't noticed, I would use a keyboard and mouse on a PC for my stuff. I'm sorry, I apologize to Xbox users. If you need to know where all these tiles are, I can't help you on that because I always type everything in. Hopefully you can figure it out. Oh, that's right. I wanted to talk about this. This is kind of a cool little trick I figured out. This page is called Initialize space 1. On here, I'm calling page Initialize, and this has a space. It's hard to tell now, but does it have a space? Initialize with a space at the end. Then I add a 1 to it. This doesn't really do anything. I could have done Initialize 1, the same name as the page, but later on I might have Initialize 2 or Initialize 3. And I can control that with this. It's kind of a handy little trick. Later on we can put this in a variable and call it based on whatever, call a particular initialize page based on whatever variable we have here. Okay, so we're calling the initialize page. And on the initialize page we need to set up some values. First we want to do this whenever the page is entered. We need to tell it how many cells across and how many cells down our grid is going to be, our maze is going to be. So, cells across, use 8. You can use any number you want here, but I wouldn't make it ridiculously large. It might affect performance. And here, cells down. Cells down. Okay. The other piece of information we need to know is the width and the height of each cell. Now, these logic cubes come in at 1 unit square, or 1 unit cube. It's 1 unit across, 1 unit deep, and 1 unit high, basically. But later on, we might want to adjust that, so it's easiest just to store that in a variable. Cell width equals 1. Cell height. Oh, I'm going to create it. Cell height also equals 1. Alright. And then the last little bit of information we need to have is the position of the cell, of each cell. So let's initialize a vector variable for that. Vector. Call it cell position. One thing I would suggest is making your variable names as obvious as possible, because you could get cute and name this, Jerry or whatever, and then a month later when you're going in here trying to fix something, you have no idea what these variables mean. So try to make them as obvious and non-creative as possible. I'm good at that. Cell position equals, we're going to just set it initially to the position of our maze generator. So cell position equals position. Right. Now, the way we're going to do this is we're going to loop through the number of cells down, the number of rows basically, and then we're going to loop through the number of columns, and in each column and row we're going to place one of our cells. So we'll use for each. Our rows first, so cells down. And then inside of that loop, this is important, we're going to loop through our cells across. It's an inner loop. So for each row, basically, and then for each column within each row, we're going to create our cell. At the cell position. At position. Cell position. Now we need to move that cell position over for the next cell. So in addition to creating this, we also want to, after it's created, adjust our cell position. It's the X component that we want to change. And we increment it. We want to move it over by the width of each cell. Cell width. Alright. So within this inner loop, it's going to create the maze cell at the cell position, and then it's going to increment the cell position over by the cell width. Now once this inner loop is done, that's the first row. Let's say this is the first row that's done. Now we need to reposition the cell for the next cell back over to the beginning of the row. And in order to do that, we need to make this a child of the main loop, not the inner loop. So just one down, or one in. And in here, we reset the X position. X equals my position, X. This resets it back to the original X of the position. So then we also need to bring it down one row, the height of the cell. So also on that same level, cell position Z. Remember it's Z because we're going along the Z axis, not the Y axis. The Y axis will make it go straight up or down. And in this case, we're going down. Decrement by cell height. Now why are we going down? These cells point to, I believe it's north, no, south. Or these objects, everything that comes in points south, which is the negative Z direction. This way would be positive Z. This way is negative Z. That's why we're decrementing these. They're going to grow down this way. Where was I? Got off on a tangent there. Okay, so that all looks good. That gets called right there. So this should work. Let's get this lined up a little bit so we can see it. Boom. 8 cells across. 1, 2, 3, 4, 5, 6, 7. 8 cells across and 8 cells down. 1, 2, 3, 4, 5, 6, 7, 8. There's our grid. Okay. Now what we want to do is we want to have a framework here for initializing and being able to control initialization of these cells. So in here we are going to say, for now, later on we'll change this to something more complicated, but for now we're just going to say, we'll set a Boolean variable called isInitialized equal to true. So this will be true as soon as each cell is created. It'll be initialized. In here, you would think that these cells would automatically report as being initialized as soon as they're created. But trust me, they're not. What we need to do is figure out a way to test that, to test when they're initialized. That's why we have that isInitialized in the cell. So after these are all created, we also need to be able to keep track of all the cells that we created. So let's add these all to an object set. We'll call this object set cells. As they're created, let's add them or increment them to the cells object set. So now we're keeping track of all. Now once they're all created, let's loop through them. And check if they are not initialized yet. When not, it is initialized. Stop doing anything. If you've seen this before, you know what this does, but for those of you who don't, this done executing, if you read the text for it, it says stops running code further down the page. When it hits this tile, it immediately ignores everything underneath it and loops back up to the beginning of the page, to the first line of runnable code, which will be here at the beginning of the page. So this effectively loops through here until each one of the cells in this object set is initialized equal to true. Then it'll go to the next line, which is this line right here. Switch page, and we need to have another page here. Let's call this stage 2. And in here, let's just, for now, display some text to let us know that we're in this stage. Maze is initialized. We'll show that at the top center, nice and big. So we can see it. That's stage 2. Let's use the same trick we use up here for, for specifying the page that we want. We'll say text stage with a space at the end plus 2. Okay. So once all these are initialized, then it'll switch to stage 2, which doesn't do a whole lot yet. On this should be initialized as soon as this code runs, right? So let's run it. Oh, let's run it. Maze is initialized, so we're good to go. Now, why do we do all that? You know, can't we just assume that all these have been initialized as soon as they're created? Well, I'll tell you why, or I'll show you why, actually. Let's count the number of frames that occur before it gets down to here. The way we do that is we just set up another number variable called frame count. And we'll increment that by 1. Every time code on this page is run, it'll hit that and increment this by 1. Okay. Now, if all of these immediately were initialized, it would go through here, hit this, all of these would pass the test, and it would go down to stage 2. It would switch page to stage 2 in one frame. So in here, let's check that. Let's change this around a little bit. Maze was initialized in come on. Plus frame count. Insert plus insert text frames. So now this will show how many frames it actually took for this code to run, for everything to be initialized. And as you can see, it took 3 frames. And this is with absolutely nothing going on in here yet. Later on, we might be performing some complex logic here. It might take more than that many frames. It might take up to 9-10 frames for all this to happen. Now, the reason we want to do that is we want to make sure these cells are completely ready and they're all on here. They're all created and ready to go before we go on to the next stage. That's why we went through all this rigmarole of checking each cell to make sure it was initialized. And we will get to that part in the next part of this series. Hope you enjoyed it. Thanks for watching.